So I'm working on a new project. This time it is about power measurement, I would say. So what I want to do is basically use such an ESP32 microcontroller to measure power. Like not any power, because if you have appliances like here, I have my AC motor, I have my it's a switch mode power supply. I'm currently charging my phone with it. And there are also other appliances which I will talk about. Those not only draw real power, but also reactive power, so apparent power. And in the video, I will talk a bit about how this works out, when which load is drawing what, but I will not go too much into detail because I already did a complete basics video about the subject. But as an example, here we got my power supply, which is currently hooked up. And here we can see the different waveforms. So we can see the voltage here, that's obvious, sinusoidal. And then here we got the current that is flowing. That is quite interesting because as you can see, there are peaks only pretty much at the top of the voltage waveform. And that is also one of the reasons why nowadays in modern society, where we use lots of such switch mode power supplies, and they all draw a lot of current at the top, that is why the sinusoidal voltage waveform is flattened at the top, because there's basically a bigger voltage drop, because that's the moment most of those modern power supplies draw their current. And as you can see, we got the current flow, which here's a big spike and then it goes a bit negative, bit positive. And basically what we have with the pink one, which I'm playing around with right now, is the power, the real power. So that's the multiplication of the voltage and the current at every point. And as you can see, it's a lot positive there. Like everything on the positive side is basically the real power. And then on the negative side, that's you will have to add those areas up in order to get the actual real power. But with the negative values, you can still see that the power factor is not 1, it is something different. But yeah, you can see it here pretty clearly how we go in the negative area. But yeah, that's kind of interesting to see on the oscilloscope. And of course, that's not all. With the microcontroller, we will sample those waveforms and then do a basic calculation. And in the end, we will get a result, which is not perfect, but pretty good, I would say, for the simplicity. So yeah, that's what I'm currently working on, and I hope you're looking forward to the video. So I'm still working on the power project, and here is a update on that. So I basically got my ESP32. I told you that before, I think. Then I got the transformer, which is used to lower the mains voltage and feed that into the ESP so that it knows how the wave looks like at which point. And then here we got the current sensor. It is a current transformer, which basically reduces the current flow, also creates this current waveform and then feeds it into the microcontroller. And the microcontroller basically samples both waveforms at the same time. So it can calculate the real power, and then it also calculates the voltage arm as the current arm as, and from that it can calculate the apparent power and then the power factor. And as an example, I got my, where is it? My laptop power supply here. And here I got my super expensive energy multimeter, which currently measures around 48 watts. Here you can see the voltage arm as and the current. But what is interesting is the power factor, which is around 0.89 or 0.9, it changes. And here are the measurements from the microcontroller. So we can see we are also getting around 48 watts. It's fluctuating a bit for the real power. Then we got the apparent power, which if we look at it, it's like 55, 54 volts ampere. And here you can see it's a bit lower. Sometimes we get 53, but it's not looking too bad. Then we got the calculations for the voltage arm as, the current arm as. And here's what I really like. It really does a good job at calculating the power factor. So here it is like 0.89, 0.88, 0.89. And you can see it here. That is also the one that is calculated by my super expensive multimeter. So yeah, this is 49, 48 volts, and this is a bit undershot here, 47 it was, 46. And it cannot also do those are pretty complicated loads with such a power supply. We can also simply hook up a toaster. I got my toaster from my kitchen here. So let's turn that on. And now we get like, wait for it. Wait, let me unplug this. Okay, toaster. Okay, my multimeter is apparently freaking out right now. Not sure why. I will see what I can do. Okay, here's the second attempt with the toaster. I accidentally pressed manual, so that's why the current range didn't update, so my multimeter freaked out a bit. But let's try that again. Turn on the toaster, and we can see it is drawing around 1020 watts. And here we can see we get 1020, 22, 23. And yeah, that's pretty much what the energy meter also measures. The power factor in this case is 1 because it's pretty much only a resistive load. And the apparent power is of course then pretty much the same as the real power. So I'm quite happy with the calculated results. Like here we got 4.5 amps, and that's pretty much what we're getting here as well, 4.5 amps. The voltage RMS 227, and here also 227. So this works pretty well. I really like this. And I will now continue integrating this Arduino code into the ESP home. So in my home assistant system. And then I can see those values on my mobile phone everywhere in the world, what I'm currently drawing in my apartment. So I think that will be a pretty interesting video. So I'm currently going through some old documents, and I actually found a video that I never released. Like I was fairly far in the production, but yeah, you can see it here. Here's the script. I filmed pretty much everything. It was supposed to be a quick episode, maybe a new format for my videos where I just go over a topic very quickly, a topic that is not that big, but apparently it didn't work out here. Quick tip, I want to call it quick tip, and it was about getting rid of the Arduino bootloader. And I did a small project, I think it was about the spot welder I did back in the days. And for that, of course, you have the Arduino bootloader, and it takes a second, I think I wrote it here, or two to load the code. So when you turn it on, it doesn't immediately get into the code you want to work with. It goes into the bootloader and waiting for a program to upload. So in the video, it was about getting rid of the bootloader by using ICSP in circuits in system programming. You can see it here. And yeah, I found all the things that I wrote down. So yeah, it's kind of funny seeing this. I did this, I think, I'm not sure, maybe 1 or 2 years ago. And maybe I still have it on the hard drive, so let me know maybe if I still have all the data. I mean, I finished, not sure if I did a voiceover though, but yeah, I can still do that. So yeah, let me know what you think about it. Hi there. So I'm working on a new video. As you can see right here, I got my setup. I'm currently filming the screen of my oscilloscope, and as you can see, there is a sine wave, but that is actually created by my oscilloscope with a low pass filter, because the board that I'm currently playing around with creates a PWM signal with a variable duty cycle here. It has a frequency of 10 kilohertz, and the variable duty cycle is basically for representing the average voltage values of a sine wave. And if we then add a low pass filter, you can see that works. I will also add a real low pass filter, an LC filter, to see that on screen as well. But the point of this video, of this short clip, is just me showing this board I'm working with. It is a microcontroller board based around an STM32 something. It is for my Arduino Alternative series, and it is the most powerful microcontroller which I showcased in this series so far. This one, it does 168 megahertz clock. There are timers, 32-bit timers even, all kinds of peripherals included. The only bad thing about this, in the sleep mode, it still consumes 1 milliamp, and also the ADC only comes with 12 bits. So those are the two cons, and the rest is just, this thing comes with a lot of power. And it is not only the power that is interesting, it is also interesting that it uses MicroPython for programming. So I will explore how easy it is to use for a beginner who maybe just has experience with Arduino. And yeah, I will go through a couple of examples. This is just one of them. I will test basically everything that is important for me: interrupts, timers, ADC, DAC, what else? Yeah, just the usage, how to program it. Is it easy? Is it easy to use? Are there the libraries ported from the Arduino? Are they there? Something like that. So pretty interesting video, I would say. It will come out soon. I am finishing up right now with the filming, and I hope you're looking forward to that. I hope that sounds interesting for you. So I am basically done with filming the new video. This video will be about a topic which many viewers have been asking me for a while now, for years. It has to do with MOSFETs. Here you can see one of the more popular ones that I always choose, the IRLZ44N. And it's basically about driving MOSFETs, like from simple tasks, switching things on and off, then going to low frequency, then going to high frequency. And the question that always pops up, this is, I think I told you about that in a previous behind the scenes clip. This is a MOSFET driver IC, which does support bootstrapping. It's pretty modern. That is why it's this super tiny SMD package. And here it does work on this breakout board. And what I'm doing is basically explaining in the video why you sometimes need MOSFET drivers. For example, with high frequencies, or when it comes to bootstrapping, what is bootstrapping? And yeah, this is a question that pops up regularly, why I sometimes use MOSFETs with the Arduino directly, why I sometimes put a MOSFET driver in between, what is bootstrapping, how does that work, and why you need it sometimes. And yeah, all those questions will be answered in the video. It will be a rather long video, but I think it's overdue. I wanted to talk about this subject for a while now, and I think it will be super interesting. You will learn a lot, and it will actually be a two-part video series. The first one will be this, with the basic stuff like why drivers, how to use them, what is bootstrapping. And then in the next part, I talked about that in a previous clip also, it will be about MOSFET driving still, but then with gate drive transformers. So as a practical example, I will show you a Tesla coil, how that one is built, the driver circuit, and then I will explain how we can use gate drive transformers. So that will be part 2. Part 1 is now in production. It will be done soon, and it should come out before Christmas. So I hope you're looking forward to that.